So now we're looking at multiple lines altogether, formed in this case to make a shape. One that looks like a rectangle. The question's asking us to prove is it a rectangle or not. So it's not good enough just to say, well, it looks like it, so it must be a rectangle. What do we know about rectangles? 4 sides. All of them cross at 90-degree angles, which means that you have to have 2 sets of parallel sides. So AD here would have to be parallel to BC. Likewise, AB would have to be parallel to DC. Since we know a little bit about slope, and we know that parallel lines have the same slope, we should be able to look at the slope of AD and the slope of BC. If they're the same, then we have some place to go. So for AD, slope is rise over run. We can use the 2 endpoints. So from A to D, the rise is 2, the run is 8. That would simplify down to 1/4. BC, we'll look at the same thing, we'll look at the slope. Again, the rise is 2, the run is also 8, so we do simplify to 1/4. So AD and BC are parallel to each other. We can go and we can look at the other 2 pairs of sides, AB. From A to B, the rise is -4, since we're moving down left to right. The run is 1. That would simplify into -4. Looking at BC, it's really DC. Looking at that, the rise is -4, the run is 1, simplifies to -4. What we have at this point still isn't quite good enough to say whether or not this shape is a rectangle. In order for the shape to be a rectangle, the sides that meet at a corner have to cross at 90-degree angles. The other way of saying that is that those sides have to be perpendicular. Knowing what we know about perpendicular lines and their slope, perpendicular lines have negative reciprocal slopes. So we have 1/4 for the long sides. The negative reciprocal of that will be -4/1, which is in fact what the 2 short sides have as slopes. So since now we've looked at the slopes and we've proven that those 2 pairs of lines are perpendicular, we can say with absolute certainty ABCD is a rectangle.